This is the pre-lab for Unit 6, the heat labs. So question 1, of course, is that you, the student, will attend the lab intensive. Question 2 is the lab on specific heat capacity. The objectives, look it up in the lab manual. You're required to look at the lab manual. This is why I do these. This is why I have these pre-labs available for you, so to make sure that you look at them. At the lab manuals, determine the heat flows of metals given their specific heat capacity and determine the experimental errors that could produce heat flow errors. Still, specific heat capacity, the theory part, you will see heat flows from a material at higher temperature to a material at lower temperature. Each heat flow is given as amount of heat equals specific heat capacity times mass times change in temperature. Due to conservation of energy in an insulated system, the heat flow out of one material must equal the heat flow into the other one, and then you can read the last statements yourself. Same lab procedures. Which temperatures do you need to record? Hot water, cold metal, mixing final temperature, and then when you do it the other way around, hot metal, cold water, mixing final temperature. The water temperature should be measured just before the metal is added, and the mixing temperature should be measured after at least half a minute to allow enough time for the heat to flow from one material in the other. And you can read through the remaining here yourself, except I'm going to do these two here. The mixing final temperature is the same for both water and metal, and the heat flows in or out of the water and the metal should be the same. So these two answers here are the same, and you can read through the others. If you look in the lab manual, you will find an example. These are the ones that are listed in the example, these 4. The other 2 may be correct, but they're not written down in my example in the lab manual. For the heat engine, the objectives are these 2 here. Measure and compute the heat, determine the efficiency of the supplied and engineer heat engines. In the theory part, we'll see a heat engine takes in a certain amount of heat, QH, and transforms part of it into mechanical work. It also loses heat in the exhaust. The efficiency is defined as eta, which is efficiency equals work divided by the heat. In both of these here are energies or measured in joules, so you come up with a fraction without units, respectively percentages. And these here should be, again, in the correct order. Question 8, let's see, procedures for the heat engines. So the DC motor shown in the video has a moment of inertia of this much, the Stirling is a moment of inertia this much, and so on. And again, you can read through these yourself, and you should look at the lab manual. Measurements for the heat engines. Turns out that actually these 2 here, the dimensions and shape of the rotating part and mass of the rotating part, are probably given in the lab manual already. So they still have to be determined, but I did it for you. And the mass of the fuel, respectively, what else we need to determine, you will see that needs to be done ahead of time anyway at the beginning of the lab. These 3 are actually the 3 that you have to measure throughout the experiment: stoppage time, frequency, and total time. But yeah, all 6 of them should be checked because all 6 of them need to be recorded.